Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And yeah, you better drop that. You better drop whatever because you drop everything for the calculus. And I know you love the calculus, so let's get right to it, shall we? This would be the solution to exam jam number 8. And remember, this is paper 2, so this really should not be all that bad. Just a little bit of thinking, All right, so we have this function x multiplied by the natural log of 4 minus x squared with the domain from -2 to 2, not including -2 and 2, right? Say yes. Yes, Mr. Becker, that's right. And that graph is shown. So wheat. And the graph of f crosses the x-axis at x equals a, x equals 0, bazinga, and x equals b. Find the value of a and b. Paper 2, hello. Let's do x times, always put that multiplication symbol in there just to be safe, 4 natural log of oh, what did I do 4 for? That's wrong. Sorry about that. X times the natural log of 4 minus x squared. Say yes. Is that right? Do I have it right? I have it right. Okay. Bam. There we go. Okay, so there's a nice little graph. Let me get that out of the way. And so A is there and B is there. So we are going to find that. So we'll go menu, analyze graph, and those are the zeros, boys and girls. So let's get this first 0, bam, bam. So that would be negative 1.73. Wonder what the other one is because it's looking quite symmetrical, but let's be sure, huh? Analyze graph, 0, bam, bam, 1.730. So A is negative 1.73 while B is 1.73. So let's write that in there. And even though there's a graph here, just to be safe, let's just re-sketch it so they know we used our graphing calculator and we didn't cheat off anybody. And so we can put negative 1.730, just a quick sketch. Nothing pretty, nothing fancy, 1.730. Bam, so we can say A equals negative 1.73 and B equals 1.73. All right, let's move forward. The graph of f has a maximum value when x equals c. Find the value of c. Well, holy schmokies. Bam, same graph. The maximum is right there. We're going to menu, analyze graph, maximum, maximum. So the lower bound, we're going to go to the left of the maximum, then we're going to go far to the right of the maximum, and we clearly see 1.15. So we go back to here, and again, you know what? You can put, since you already sketched this, you can put points. Well, no, you shouldn't do that. You should go down here and just do this, and then write. Oh, my short-term memory is gone. I forget. 1.15, 1.13. We're really only interested in the 1.15 though, because that's what C is. But we'll put the 1.13 in there just for kicks. So this is the ordered pair, 1.15, 1.13, bazinga. And so we can say C equals 1.15. And we have that sketch there. Okay. C. The region under the graph of f from x equals 0 to x equals c, bam, is rotated 360 degrees about the x-axis. Find the volume of the solid form. Okay, so you panic and you're like, I forget the formula, I forget. I don't know what to do, Mr. Becker. Where's my formula booklet? I'm going to have to quit this because it's being mean. Hold on. Come on. Go ahead and quit. I got to open it back up, and then it's going to let me open the formula booklet. Sorry for the delay. Where is it? History, yesterday, today, formula booklet. There we go. Okay. And if you go to calculus, if you forget the formula, we go down, down, down. Baby, are you down, 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 down? Volume of revolution, boys and girls. There we go. So I'm going to take a quick pick of that. And bam, put her in just for kicks. Okay. And I'll move it over here, and I'm going to get rid of it so we have room to work. Or maybe I might not even have to. Okay, so the volume of revolution about the x-axis from x equals a to x equals b is given by pi y squared, where y is the function. Remember, y is another way to write f of x. Okay, so this would equal volume would equal the integral from a to b. So they say from 0 to c, so that's going to be 0 to 1.15 of the function x ln of 4 minus x squared dx. And hopefully you're going, hey, Mr. B-Dog, you forgot two things. You forgot the pi. Well, I'm just going to put pi up front, or you can still put it in there. It doesn't matter. Here's the biggie that everyone forgets. You have to square the function. You got to square the function. So I am going to do this and square it. And now all we have to do is crank that in our calculator. So we'll go to our calculator. I'm going to forget that. Am I going to forget that? No, I'm good. Okay, so we go to our calculator, and we have a graphing page, so we have to add a calculation page. Add calculator, menu, calculus, numerical integral, and a monkey could do this. It's so easy. So we're going to go from 0 to 1.15. And we're going to go, let's see, you're going to have to use your parentheses wisely here. X, nope, what happened there? X times natural log of 4 minus x squared. And then you're saying, well, Mr. B, why'd you need these outside parentheses? Remember, I have to square it. Yes? Don't forget that freaking square. I don't want to come attack you during the summer. And then I'm going to put pi in front. Pi times that. Okay? Bam. Could it be any easier? The volume is equal to 2.16. So we would say approximately equal to, you can put equal, they're not going to care, 2.16. Wham bam, thank you ma'am. And that, I mean, how you're following a formula, you know about volumes of rotation or solids of rotation, should be an easy deal for you. All right, last one, D. Let R be the region. This is the only part, figuring out what the heck they're talking about. Let R be the region enclosed by the curve. Got it. The x-axis. Got it. And the line x equals c. Between x equals a and x equals c. So it's from here to here. So we're talking about this region and this region right here. Okay. Let me back up before I write this. I want to emphasize, you have to write this. You have to write this so they know you didn't, use the sneakoscope to look at someone's paper. Otherwise, I don't think you'll get any credit with just the answer. So make sure you write out the integral, and make sure you write out these integrals. Okay. So area under the curve. Let R be the region enclosed by the curve, so the area is going to be equal to, we have two separate integrals that we have to do. We have to go from here to here. So that's equal to, Now here's the tricky part, boys and girls. This is under the curve. So if we went from A, which is negative 1.73 to 0, we would end up with a negative value. Okay, and that comes into play with an application. It would be negative. But they are asking simply for the area, and area is positive. So in order to compensate for it being under the curve and making it positive, we just have to put a negative out in front. And so we're going to, again, go from negative 1.73 to 0, okay? And we would just have to integrate our function, which is x natural log of 4 minus x squared dx. And then we're going to add the integral here, the integral from 0 to 1.15, and life is good because this is above the x-axis, so there's no worries here. And let's see, we would put in the function again, x natural log of 4 minus x squared dx. And if you write that, you're going to get the majority of your points because they know you know what you're talking about. And now it's just calculator work. Please, please, please don't try and integrate anything on paper 2 that has bounds. Use your calculator. Okay? So let's do that real quick, and that'll be the last thing here. So menu, the calculus, numerical integral. First one is negative. Oh, I got to put a negative in front. Don't forget, negative. And then we're going to do negative 1.73 to 0. And I'm going to try and copy this just to save a little bit of time. See if it works. Bam, I am awesome. That's right, dx, don't forget your dx, plus, oops, no, go outside there, plus another integral, menu, calculus, numerical integral. Now we're going from 0. Remember C was 1.15. I probably could have copied that whole thing and gotten rid of the whole squares or whatever. Put in the function. Then we're going to go dx. Bing, bang, boom. Oh, I got to Skype with you guys. And we get 2.06. We have guests. I'm almost done. I'm like 1 second away. Almost done. We have all kinds of special guests coming here, and they're going to kick me out of the conference room. Okay, so that area is equal to 2.07 rounded to 3 sig figs, and that would be, we would just write that down, equals or approximately 2.07, and we are good. That is it. Let's go back and see how drop dat is doing. Are we still dropping that? I think we are. That is all I have. Hope you enjoyed exam jam number 8, and we are out.